Hello students, so let's go for quick revision of Compton effect. So this is very important experiment and we should focus which formula we should learn and what is the basic concept for the Compton effect. And this revision is only for the IT JAM examination. So we should just see where we have to focus. So the experiment is very simple. You have electron and this electron is assumed to be free and there is some light is coming and this light has some frequency nu or it has some wavelength lambda, and after the collision this light wave have changed its wavelength and with something nu dash and lambda dash, and this electron will recoil into some another direction. So this is axis of incident of this particular incoming wave. So this angle is phi, this angle is theta. Theta is the angle of recoil. So these are the schematic diagram of Compton effect. So where you have to focus? You have to focus first this formula, this lambda dash minus lambda is equal to h upon m naught c 1 minus cos phi. So this is one of the very important formula. Phi is the angle for which this scattered wave is going on with respect to this particular axis, and this axis can be measured in which direction the incoming wave is coming. So this is very important formula, and here you have to also remember this particular value. Sometimes this particular value can be written as lambda c, and h is Planck constant, m is mass of electron. So h upon mass of electron into c, and this value is you have to remember 2.46 into 10 to the power minus 12 meter. So this is one thing you have to remember. The another thing you have to remember that what is kinetic energy of recoil electron. So kinetic energy of recoil electron. So this kinetic energy of recoil electron is basically, you have to just write the value, that is hc upon lambda minus hc upon lambda dash. This is kinetic energy of recoil electron. But if someone will ask you what will be the total energy of recoil electron, then you have to write this thing: total energy is equal to kinetic energy plus rest mass energy of electron. And what is this total energy? This total energy is equal to p square c square plus me square c4. So this is your total energy is equal to kinetic energy plus me c square. So this is one of the very important formula. Most of the time they are asking directly this formula. And also you can remember the conservation of momentum formula for x-axis and y-axis. Suppose electron is recoiling with the momentum p, then you have to also remember this formula: p sine theta is equal to h nu dash upon c sine phi. This is for the y-axis conservation of momentum, and for x-axis conservation of momentum, p cos theta is equal to h nu upon c minus h nu dash upon c cos phi. This phi is all about angle of scattering, and theta is the angle of recoil. So from here you can also calculate this value, that tan theta is equal to sine phi by nu upon nu dash minus cos phi. And this is the relationship between angle of scattering and angle of recoil of electron. So this is also very important. you should not remember this formula, but you should know how you can resolve the momentum part into x direction and y direction. And this is conservation of momentum, and this is conservation of energy. So this thing you have to just practice such that sometime they can give you all the schematic diagram and you have to calculate each and everything. Please remember, phi is angle of scattering and theta is nothing but angle of recoil of electron. And this number is for mass of electron. So you should also work with for mass of proton. What can be this number? So in general, in exam, they will just uh, scattered with the electron, but you have to be very much focused whether it is electron or proton or something else. And everything is very simple and straightforward. And this particular Compton effect will just tell you all about the particle nature of light. So the conclusion is that this is particle nature of light. Particle nature of light. And this change in wavelength will not dependent on the incoming wavelength. This will only dependent on this particular scattering angle phi. So this is very important. This is just a change in wavelength. So this lambda, so you can write something like this. This lambda, delta lambda is equal to lambda c 1 minus cos phi, where lambda c for the electron is this particular number. So this is all about quick revision of Compton effect. This is very important topic. And in your JAM examination, there will be at least one question from at least this formula or combination of this conservation of momentum and conservation of energy. So this is all about Compton effect. Thank you.